All right, everyone, now we're going to look at the idea of solving logarithmic equations. So we've looked at exponential equations, now on the other side, logarithmic equations. Now it's important first to make sure you have your properties down because we're going to be using those when we kind of condense these down. So we will have to condense the logarithmic function before we start. So the first thing we do is notice how they all have the log base 3, okay? And so we're all going to combine them together, and you'll notice that log base 3, and with addition, that means 6 times x, which equals log base 3 of 2. Okay, so let me quick review that. Remember, addition, if we're going to condense logarithmic equations, that becomes multiplication. So log base 3 of 6 times x equals log base 3 of 2. Now, the nice thing is it's similar to exponential functions in saying that we both have log base 3. And because of this equal sign, because they both have the log base 3 here, therefore, this portion right here has to equal this right here. So 6x equals 2. And so now we just solve for x, and we're left with a simple just x equals 1/3. Okay? So when we're given a one that has the bases already on both sides, then it makes it fairly easy to just kind of condense everything down and then set the parts equal to each other. So that leads into example 2, where we don't have necessarily the log base 4 on this side. So let's first start out by condensing this thing. So we have log base 4, 3. Subtraction means we're going to divide, equals 2. Okay? So we have to do a little bit of planning here. We have to change this 2, this whole number, into in the form of a log base 4 in this case. Okay? So another way to write the number 2 with a log base 4 would be, if you're kind of thinking about it, would be log base 4 of 16. Okay? Now think about this for a moment, and that is that we have, let's say for example, log base, we want to have log base 4. We don't know what to put here, but we know that it has to equal 2. Alright, so we want this log base 4, but we don't know what to put here. So if we write out in this way, and you transform it into an exponential function, in terms of 4 to the second power equals what, you'll find that what goes in that spot. Okay, so log base 4 of 16 is the equivalent to the number 2, but we write it in this way so that we're able to set the two portions equal to each other. Okay, it's very similar to, let me throw out this just quick example, 3/4 plus 1/3. Okay, so if I give you this as a problem, you're like, oh man, I can't combine those together. But if I have common denominators, for example 9/12 plus 4/12, we now are able to put them together because they have the common denominator. In a, not necessarily extreme way, but in a similar way, we are not changing the value of 2. We are simply just making with a log base 4, so we're able to complete the problem. Okay, so now we have 3 over x equals 16. So now that we have log base 4 on each side, we take each portion and set it equal to each other. And in this case, I introduced I produced this problem just to practice this particular skill, that if x is the denominator, we can do one of two things. We could set it up as a proportion, which you get the same answer, or we can multiply both sides times x, kind of showing the more algebraic way, in which we would get 3 equals 16 over x, or 16 times x, and then to solve for x we divide by 16 and get 3 over 16 equals x. Okay, so kind of, again, some algebra there. Really the only thing we're practicing with the new stuff is just transforming possibly whole numbers into logarithmic functions, and then we're just having some simple algebra. So let's talk about this. Again, we're going to use our knowledge of properties of logarithms to simplify this down a little bit into one logarithm. So we have, now understand that this, because this is in front, we have log base 5x squared minus log base 3 equals 2. Alright, and so because that 2 goes up in front, I'm condensing this down, so we now have log base 5x squared divided by 3 equals 2. Again, because the subtraction sign is division. Alright, next thing I need to do is I need to have a common, the log base 5 on this side. So you got to think, okay, how do I transform log base 5 of something into 2? Alright, so you could use the same scenario we just used, which is x squared over 3 equals log base 5 of 25, if you guessed correctly. 5 squared equals 25. And now that we have the same log and the same base, here we can set the two portions equal to each other. So now we have x squared over 3 equals 25. And to solve this, all we have to do is take both sides times 3. Times 3, we get x squared equals 75. And then we square root both sides, and we're left with x equals plus or minus the square root of 75. Now, if you're into simplifying radicals real quick, we do have plus or minus, in case you remember, 5 square root 3. And means we want to break it down into 25 and times 3. You could also do that. But plus or minus square root of 75 will be okay, but just in case, sharpen up on your radical skills, that'll work as well. Alright, so hopefully this video kind of helped you with the basics of solving logarithmic equations, and we're ready to go for this next section. Thank you.